All right, so 5.3 goes over trig functions with any angle. With the first slide that we look at here, we're given a triangle that you see here that's in that A figure, and we're just putting it in standard position. Putting it in standard position is like putting it on a coordinate plane, where your one side is going to be on your x-axis, okay, so this two side lengths that form your right triangle will be on the x-axis, and the one that touches the x-axis is going to be your x value. The one that is going up and down vertical is going to be your y value. Your hypotenuse is going to be called or considered r. R is found by taking the square root of your x value squared plus your y value squared. So you're going to have an x and a y with these, so ordered pairs that give you your theta for these triangles or these angles. And you're going to be forming a triangle out of them with the given values. So in order to find your x, it's just going to be the x value of the coordinate, the ordered pair. The y is going to be the y value from the ordered pair, and r is going to be the hypotenuse. Your r is found by taking x squared plus y squared and finding the square root of it. With this, once you find your x, your y, and your r, you are going to be using what's down here in order to find the sine, cosine, tangent, cosecant, secant, and cotangent. So sine is just your y value over r, cosine is x over r, tangent is y over x, cosecant is the reciprocal of sine, so it's just r over y. Secant is the reciprocal of cosine, so that's r over x, and cotangent is the reciprocal of tangent, so that's x over y. With this, when you evaluate these trig functions, you want to think of something that's going to help you. It has it here in your notes. This all students take calculus. Within your coordinate plane, you have different signs for your ordered pairs. In the first quadrant, which is this top right quadrant where it says all, that is going to be positive, positive. So your x and your y are both positive. For the second quadrant, your x is going to be negative, your y is positive. For the third quadrant, your x and y are negative, and for the fourth quadrant, your x is positive, your y is negative. This is going to help you when you are told to evaluate these. The reason why is because when you're given, let's say, the tangent of something and it's negative, you don't know whether it's the top or the bottom of that was a bad example. If you're given the sine or the cosine of something, and it's something like the square root of 2 over, or the negative square root 2 over 2, you would not know right from looking at it which is your negative term, either your x or your y or your r. So with this, it's going to help you identify that. For your all, it's every single trig function. So they would all be positive. So x and y would be positive. R is always going to be positive. For the sine, it's just your sine and its reciprocal. So sine and cosecant that are going to be positive. So sine, cosecant is positive. For the tangent, you'd have tangent and its reciprocal, so cotangent. For cosine, it'd be cosine and its reciprocal for secant. Again, all is all of them. Sine, cosine, tangent, cosecant, secant, cotangent. For your next part is just determining these quadrants. So it tells you that sine theta is less than 0 and tangent theta is greater than 0. So your sine would be negative then if theta is less than 0. So sine is negative. The tangent would be positive if theta is greater than 0. So tangent is positive. From here, you want to think about your coordinate plane. All students take calculus. Where is your sine and your tangent? Sine would be negative, tangent would be positive. That means that you would have sine positive, sine's negative, tangent is positive, you have your all. So then from here, your tangent that's positive, you would also have here as well. So what you're looking at is where that tangent is positive, which would just be in quadrant 3. With your secant theta is greater than 0, it just means that your cosine of theta is positive, and your cosecant, this should be a C, not an S, of theta is less than 0, so your sine of theta is negative. So again, when you're looking at that coordinate plane, all students take calculus, you're looking at the one where it works, which would just be quadrant 4. For our first example that we're going to be looking at, we're determining the 6 trig functions. So we're going to need a couple things with this. With this, you're going to need the plus or minus chart, so your coordinate plane, sort of say, to see this is positive, positive, this is negative, positive, this one is negative, negative, and this one is positive, negative. You're also going to need to know sine is y over r, cosine is x over r, tangent is y over x, cosecant, secant, and the cotangent are the reciprocals of those. I'll write those down once we get to them. So with this one, this first example, we have tangent theta is equal to negative 5 over 3, and theta is in quadrant 4. When I look at these, I don't even pay attention to that theta is in quadrant 4, specifically because when I look at tangent, I have negative 5 over 3. Tangent is y over x. Do I know which is my negative? Not necessarily, because when I do a fraction, my negative either goes up top or out front. It doesn't stay with my denominator. So if tangent is y over x, that means that my x value is going to be a 3, my y value is going to be a 5. But I don't know which of these is positive and which of these is negative. If you look at quadrant 4, it will then tell you that your x is positive and your y is negative. So then x would be the positive 3, y is negative 5. However, you don't always need to use that in order to find out whether or not you have a positive or negative. You could also use a unit circle in order to find that as well. So if theta is negative 5 over 3, and we're doing the tangent, that's y over x, we're going to find for r, because we're missing the r. To find for r, you're going to take the square root of x squared plus y squared. So that's going to give us the square root of 3 squared plus negative 5 squared. 3 squared is 9. Negative 5 squared is 25. 9 plus 25 is 34. So it's the square root of 34. From here, we have an r, we have an x, we have a y. We said that sine is y over r, which is going to give us y, which is negative 5, over r, which is the square root of 34. You cannot keep the square root of 34 in the denominator, so multiply top and bottom by the square root of 34. This gives us negative 5 square root 34 over 34. Next we have cosine. Cosine is x over r. We said our x is 3. Our r we found was the square root of 34. So again, rationalize the denominator. Multiply top and bottom by the square root of 34. This gives us 3 square root 34 over 34. Next we find tangent, which we had. That's y over x. That gives us negative 5 over 3. Next we find cosecant, which is r over y. R over y is going to give us the square root of 34 over negative 5. That negative 5, that negative goes in front or up top. For the reciprocal of cosine, we have secant, so that's r over x. So that's the square root of 34 over 3. And then the reciprocal of tangent, we have cotangent, which is x over y. So that's 3 over negative 5. And again, the negative goes either out front or with the numerator. So giving these, or listing all 6 of these, our sine is negative 5 square root 34 over 34. Our cosine, let's do it this way. Cosine is 3 square root 34 over 34. Our tangent is negative 5 over 3. The reciprocal of sine is cosecant, which is the square root of 34, or sorry, negative square root 34 over 5. The reciprocal of cosine is secant, so that's going to be the square root of 34 over 3. And the reciprocal of tangent is cotangent, and that's negative 3 over 5. For our next example, it tells us that secant of theta is equal to negative 2, and theta is in quadrant 3. If theta is in quadrant 3, our ordered pair is negative, negative. Secant is the same thing as saying r over x. This negative 2 is over 1. Do we know what goes with the negative? Well, yes, because we're dealing with r. R is never negative, so x is automatically the negative 1. R is the 2. We got to find for y. We know r is equal to the square root of x squared plus y squared. So this is going to give us r, which is 2, is equal to the square root of negative 1 squared plus y squared. We're finding for y. So 2 is equal to the square root of 1 plus y squared. We square both sides. This gives us 4 is equal to 1 plus y squared. Move the 1 over. We get 3 is equal to y squared. Take the square root of both sides. We get that y is equal to plus or minus 3. Now, how do we know if it's positive or negative 3? Look at your ordered pair. It's in quadrant 3, so your y is also negative. So it would be the negative 3, not the positive 3. So we're using y is equal to negative 3, x is equal to negative 1, and r is equal to positive 2. To find sine, we have y over r. Y we said was negative 3 over r, which is 2. Cosine is x over r, so that's going to be negative 1 over 2. Tangent is y over x, so that's going to be negative 3 over negative 1, which is just positive 3. Cosecant is r over y, and that's not the square, it's the square root of 3. I'm sorry. This is the square root of 3, negative square root 3. So this one is the square root of 3. This one is the square root of 3. This is also square root of 3. Okay. So cosecant r over y, r we said was 2. Y is the negative square root 3. To rationalize this, we're going to multiply top and bottom by the square root of 3. So this is going to give us a negative 2 square root 3 over 3. For your secant, we have r over x. We said r is 2, x is negative 1, so that's just negative 2. And then cotangent is x over y, so that is negative 1 over the square root of 3. We rationalize the denominator. This is a negative square root of 3, I'm sorry. And we get square root 3 over 3. So all of this is our answer. If you wanted to rewrite it like we did the one before, you can do that too. It's the same exact thing. From here, we are going to be looking at coterminal angles. When we're working with two coterminal angles, you want to keep in mind that starting off, you're at 0. You go up to be at 90 degrees, then 180, 270, and a full rotation is 360 degrees. Now, these angles will go past 360 degrees, so they will go bigger, or they will be bigger than 360 at some point. All right, so with our next example, we're just finding the cosine of 135 degrees and the tangent of 390 degrees. Again, you have to keep in mind what we were saying before this about how if it goes over 360, you got to keep that in mind and take that into consideration when finding the correct degree when looking at your unit circle. The first one we're going to look at is that cosine of 135 degrees. We look at our unit circle and we find that 135 degrees. It is here, so we're working with the ordered pair of negative square root 2 over 2, square root 2 over 2. From here, identify your x, your y, and your r. X is negative square root 2 over 2. Y is the square root of 2 over 2. We got to solve for r. R is the square root of x squared plus y squared. So that's negative square root 2 over 2 squared plus square root 2 over 2 squared. This is going to give us 2 over 4 plus 2 over 4 underneath that radical. So that's 4 over 4, which is the same thing as the square root of 1. Square root of 1 is 1, so our value is 1. If we're finding the cosine, we are going to be looking at x over r. So we said x is the negative square root 2 over 2 over r, which is 1. Anything over 1 is itself. So the cosine of 135 degrees is the negative square root 2 over 2. For example B, we have the tangent of 390 degrees. If we look back at our unit circle, 390 degrees is more than 360. So we're going to take the 360 degrees and add 30 to it. We're at that square root of 3 over 2, comma 1/2. So we're going to use that as our ordered pair. From here, we have an x, we have a y. X is the square root of 3 over 2. Y is the 1/2. Oops. We got to find what r is. So r is equal to the square root of the square root of 3 over 2 squared plus the 1/2 squared. This gives us the square root of 3 over 4 plus 1 over 4. So again, we have 4 over 4 underneath the radical. So that's just the square root of 1, which is 1. So r is 1. We're finding the tangent of 390 degrees. Tangent is y over x. Did we need to even bother with finding r? No, we could have just realized from the beginning we're finding tangent. We only need x and y. We're going to plug our values in. So that gives us y, which is 1/2, over x, which is the square root of 3 over 2. When we divide fractions, we keep change flip. So 1/2 divided by the square root of 3 over 2 is the same thing as saying 1/2 times 2 over the square root of 3. Those 2's simplify, so it gives us 1 over the square root of 3. We rationalize that denominator, and we get the square root of 3 over 3. So the tangent of 390 degrees is the square root of 3 over 3. With our next set of examples, we're working with reference angles. If you remember in the past with reference angles, if you let's say you were in my Algebra 2 class, when we did reference angles, we added or subtracted 360 until we got a positive and acute angle. So our whole idea with these reference angles is to end with a positive angle that's also an acute angle. So something less than 90 degrees that's positive. For these, you have to, some of them are going to be given to you in degrees, some of them will be given to you in radians. You'll have to change them depending on what they're given to you as. So with these, if we look at example 2, we're finding the reference angle for each of these. For A, it gives us theta is 5 pi over 3. Turn that 5 pi over 3 into degrees. Multiply it by 180 over pi. Your pi's cancel out. 3 becomes 1. 180 becomes 60. So we're just doing 5 times 60, which is 300 degrees. From here, think about where the 300 degrees is. On your coordinate plane, your 300 degrees is about here. So how many, or what would be that reference angle for it? If we take the 360, subtract 300 from it, we get 60 degrees. So that would be your reference angle. If it was given to you in radians, it has to be given, your answer has to be given to you given as radians as well. So turn your 60 degrees into radians. So multiply it by pi over 180. The zeros cancel. 6 becomes 1. 18 becomes 3. So that's pi over 3. For example B, we're given that theta is 870 degrees. For this, I'm going to start by subtracting 360 from it. This gives me 510 degrees. This 510 degrees is still more than 360, so I'm going to subtract 360 from it again. I get 150 degrees. From there, now, this is why I was saying prior to this that sometimes you'll need the arrow or the angle on the coordinate plane, sometimes you don't. I don't think that it's necessary. However, if it helps you, use it. If you were to use it, that 150 degrees is in your second quadrant. So, with that, I would take 180. I'm looking for a positive and an acute angle. I would take 180 degrees and subtract 150 from it and get 30 degrees. Another way to do it is to just see how much is between the 150 degrees and the 180 degrees on your plane. So in this case, your reference angle is just the 30 degrees. We're going to continue to find reference angles. For example, for A, we're given sine of 16 pi over 3. So I want to turn this 16 pi over 3 into degrees so it makes my life a little bit easier. I'm going to multiply it by 180 over pi. The 3 becomes a 1, 180 becomes 60, so I'm doing 16 times 60. 16 times 60 gives me 960 degrees. So I'm finding the sine of 900, or not the sine, I'm using the 960 degrees to find the reference angle. So again, it's greater than 360, so I'm going to subtract 360 from that. I get 600. From there, I'm going to subtract 360 from that, and I get 240. Again, I ask myself, is 240 closer to 180, or is it closer to 360? Well, if I did 360 minus 240, I get 120. That's not going to give me an answer that's an acute angle. So I'm going to take the 240, and I'm going to subtract 180 from it. 240 minus 180 gives us 60 degrees. So I turn that 60 degrees back into radians since I was given radians to start with. That's pi over 180 that I multiply it by. The 80 and the zeros cancel out. The 18 becomes a 3, 6 becomes a 1. So that's just pi over 3 radians. Now for example B, you're going to work around in circles pretty much. It gives you the secant of negative pi over 4. This negative pi over 4, turn it into degrees. When you turn it into degrees, multiply by 180 over pi. Your pi's cancel. The 4 becomes 180 divided by 4 is 45. So that's 1 and 45. Okay, so this is just negative 45 degrees. If we find the reference angle for this, we want a positive acute angle. If we took 360 and we subtracted the 45 from it, we get 315 degrees. If we drew that on our XY plane, that 315 degrees is here. From there, you would go up to 360. So you would take the 360 and subtract 315 from it, and you'd be left with 45 degrees. So you would then turn the 45 degrees into radians, which technically was already given to you because that's what you turned the negative pi over 4 into. So it would just be a positive pi over 4 radians for your reference angle for this one. The last part of our notes goes over finding the area of a triangle where you have an angle between two side lengths. These two side lengths have to be surrounding that angle. If it doesn't, you cannot use this formula. So your area for these types of triangles, you're going to use your A times your C times the sine of B divided by 2. So what does this mean? Our A is 3, our A is C, our A is 3, our C is 10. We multiply those together, we take the sine of the angle that's between them, and then we get that answer divided by 2 will give us our area. So if area is A times C times the sine of B over 2, we're going to have A is equal to 3 times 10 times the sine of B, which is 120 degrees, over 2. This is going to give us 30 sine 120 divided by 2. Use your calculator. 30 times the sine of 120 divided by 2 gives us 15 square root 3 over 2, which is 12.99 centimeters squared.